screen share है? Are you sharing the screen? Good evening, everyone. Am I audible?
Yes, ma'am. Good evening.
Okay, thank you. Can you see the shared screen, whiteboard? Can you see?
Yes,
Yes, ma'am.
ma'am.
Okay, nice. So today we are late. Okay, so I'll be starting quickly, immediately. Till now, we in both classes, previous sessions, we have done about the introduction of statistics, its application, tools for management, and one tool we have done, that is measures of central tendency. In that tool, we have discussed about the mean, median, mode, and the related positional values. We discussed about the quartiles, percentiles, deciles yesterday, and we finished winded up that. So second tool which we are going to study, that is important, an improved version of measures of central tendency. I'll discuss why it is an improved version. I'll explain you in detail. So that is measures of dispersion. So measures of dispersion, in this we are basically going to study about the variations. Now in measures central tendency, we discussed about mean, median and mode. So whenever we discussed about mean and median, we basically discussed about the central value. How to calculate for all observations, right? We have discussed. But why this measures of dispersion is an improved version of measures of central tendency? Because this is the actual tool where we can see how much is the variation for the given data. I'll explain you through example. For example, there are two factories and the employees are working, and in one factory the employees are taking, one employee, for example, any one employee is taking 15,000 rupees per month, and there is second factory and the employee is taking 18,000 per month, right? Now you may think that's the employee who's taking second, the employee who is working in second factory who is taking 18,000 per month, that is better, so we should go for that option. But it's not actually true. Why? The reason may be, in factory 1, the person who is taking 15,000 may have less working hours, may have less workload, may have weekends off. So these are the facilities which are given in factory 1, and the person is getting 15,000. Now the person in factory 2 is getting more salary, 18,000, but may have a longer working hours, may not have weekends off, may have too much of workload. So people will not prefer working in factory 2. People will prefer working in factory 1 because facilities are better than working too much. If we get facility, that is much better. Same way, when people go to have a scenario for the schools, they see, I gave you example, they see the facilities, whether the classrooms are equipped only with fans or the classrooms are equipped with ACs. They will see whether there is only one cricket sport or they have multiple sports, whether they have meals provided in the school or whether they have to bring tiffins from home. So these are the facilities. So how we judge whether the given data is, how much is the variation from the central value, from the mean? For that, improved version is made, that is measures of dispersion. So meaning of dispersion is wait okay, next page. So meaning dispersion indicates the variability, variations of the observations. That is the how much is the spread, how much is the scattered items from the central value. So central value is the mean, which we have already discussed. Now the average is very meaningful when it is examined in the light of dispersion. I gave you the example of a person working in factories. Now it is noted that if the mean of the observations, though the mean of the observations may be same, but the variation is too much. I'll give you example. For example, we have 3 series, A series, B series and C series. Now in these series, just a second, I'm having a call, just a second. हेलो, अच्छा अच्छा ठीक है, भेज रही हूँ. बच्चे okay. Now for series A, for example, let us have the observations 100, 100, 100, 100, again 100. All values are 100. Total will be 500. In series B, let the observations be 100, 105, 102, 103 and 90. Again total is 500. In observation C, values are 1, 489, 2, 3 and 5. Again total is 500. Now the total is same. If I calculate the mean of observation A, mean of A, it will be 500 upon 500. Here the mean, again mean is 500 upon 500. The mean for series, again it is 100. Now we can very easily see that the mean in all the series A, B and C are same. But can you see the data carefully? In A series there is no variation. There is no spread, no variation. In B series, from central value, this is central value, this is same, this is little variation, little variation, little variation. So here there is less variation. There is variation but very little. Now if you see the series C carefully, you can very well judge that this is 1 and this is central value is 100. This is 489. Mean is 100. 2 and mean is 100. So you can see the variation between the values from the mean. It's too high variation. I hope why we are studying dispersion is clear to you. Just to see the variation in the data, though the mean is same. Now we can easily say that yes, mean of all observation is same and the observations are very near to the mean. But no, it's live example in front of you. In A there is no variation, in B there is less variation, but in C there is too much of variation. So in order to judge the correct variation, correct tool, we use improved version, that is measure of dispersion. Right? I'll explain you graphically quickly. For example, I have 3 graphs. This is A graph, this is B graph, and this is C graph. Now in A graph, it's comparison of 2 series. Now here, for example, this is the distribution of first series. Let this be the distribution of another series. That means if we see the central value, it is same. That is mean is same. Mean is same. Here, okay. Now in B observations, let this be the first representation, the graph for first series, and having mean x1, and this be the mean of second variation, that is mean x2, and in third let this be the spread of first series, let it be mean having mean x1, and this is the spread of second series having mean x2. Now what is the observation from A, B and C? Now A represents 2 distributions having same mean, clearly seen in A part, having same mean, but the dispersion, the variation, the spread is different, because this is the distribution of first series and this is the spread of second series. Though mean is same, but the spread is different, means dispersion is different. Now B represents 2 distributions with same spread. Now the spread of this and the spread of this is same, but means are different. C represents 2 distributions with unequal variation. Here the variation is more and here the variation is less. So C is having unequal variation. So through graphical representation also we can study the variation, study the spread. If we know the mean, we can plot and then we can see how much is the variation in the data. I repeat, in first one mean is same but having different variation. In second, variations are same but having different mean. In third case, means are also different and dispersion is also different. Right? So basically dispersion refers to, it is measuring variation, that is degree, but not the direction. Right? And it is why we study dispersion. It gives more reliability of an average. We know how to calculate average, but if we calculate measures of dispersion, then it is more reliable. And how much is the how to control the variation? We need to have the control in the variation. We need to study dispersion, and in that way, in that value, we used to find means of two series, of one series. But here we can find the variation of in comparison. Means what is the dispersion for first series, what is the observation for second series. We can compare, right? So next is the brief introduction for the measures of dispersion. Now the explanation part is when dispersion is small. If dispersion means variation, if dispersion is small or less, then if the variation is less, obviously our thinking says then the series is more reliable. Series is more reliable. More reliable means it has more consistency. It has more consistency. Consistency means something which is in good proportion, accurate proportion. I'll explain you the meaning of consistency with the example. You want to bake idli, right? And you are just mixing the batter in random way as per your choice. You don't know what should be the proportion of suji, curd, salt. You are just mixing in your random way. So when you see the consistency, when we are not aware of the proportion of the material to be used, the consistency will be very poor. And if we know that for 8 idlis we need this much cups of suji, this much cup of curd, this much pinch of salt, this whatever spices. If we know the proportion, then the consistency of the butter will be very good. That means if the variation is unequal in any way, then it is not reliable. It will be very, very poor consistency it will have. And if you know the proportion, variation is less. If you know the accuracy, then that butter will be more reliable, more consistent. Same way, other way, vice versa. If dispersion is more or large, then the series is less reliable. Less reliable means less consistent. So how to check the consistency, how to check the variation? We use the tool. Another example can be, for example, I want to see the body temperature. You use the thermometer and your body temperature keeps on changing if you are working in a hot weather outside, somewhere outside, in garden or park or a road, anywhere, then your body temperature would be more. And if you are sitting under the AC throughout the day, your body temperature will be less, because AC is giving you less AC is making you cooler. right? So body temperature depends on situation. There is variation in body temperatures according to the variations in the environment. Similarly, pulse beat. If you are running, doing jogging in the evening, and immediately then you check your pulse beat, it will be very, very fast. If you are climbing the stairs from ground floor to fifth floor, your pulse beat will be very fast. But if you are just sleeping for past 1 hour and you check the pulse beat, your pulse beat will be very less. So your pulse beat also depends on your actions. Similarly, BP, blood pressure. If you are annoyed with someone, you are in argument with someone, your BP will rise. Your face will turn red. And if you are very calm, no argument, happy person on this earth, then your BP will be normal. So BP these days is a common problem we have in adults, we have in adolescent children. This is the major problem we face. Even now kids also have BP. So we need to be very, very vigilant. Okay. So there is a variation, right? And in industrial problem, or we can say in businesses, there is variation in inflation or deflation. Sometimes it is too good season, peak season, very good sales, very good demand, very good income. So it is inflation period. And if there is a the trend is going down, or a market is not having sale, or goods are not in demand, then it is variation in the, there is deflation and there is too much of variation. For example, another example can be inequality in the income. Some people work in factories, they earn 10,000 per month with more working hours, and some people work in companies, they work for 6 hours and they earn in lakhs. So there is variation, too much of variation. It's all income also depends on the type of work the person is doing, right? Okay. So now we'll be studying the procedure. What are the methods of studying? Methods of studying variation or dispersion. Variation or dispersion means the same. So first method I will be teaching today is range. You must be aware of. If you are not, it's okay, I'll discuss. Then is quartile deviation. We have studied about quartiles yesterday. Upper quartile, lower quartile we have discussed. Quartile deviation is what I'll teach you today. Then we have mean deviation. Mean, or we use the word average, meaning is the same. Mean deviation. Then we'll discuss about standard deviation. This is the most important, the most important. These are the 4 topics which we'll be studying. Let's see how much we can cover up today because class started late. So I'll try to cover first 3, but if the third one is not complete, then we'll continue tomorrow. And yes, one announcement, children. Tomorrow the class will be in morning 8 to 10. I have told sir, I told sir that class will be tomorrow. So I think sir will inform you. Class is tomorrow 8 to 10, morning 8 to 10. Right? Standard deviation I think I have to cover tomorrow, but I'll try to cover first 3 topics today. Let's start. Any idea, children, from your side? Let me hear from you. Any idea about range? It's an easy one. I think you must be having an idea. What is range? Any idea from your side? What is the range? No idea? Nobody knows what is range? Okay. So if I go to a shoe shop and I ask shopkeeper to you have the shoes of which number, so shopkeeper says that I have the shoe starting from the shoe number 4 till 11. So I say, okay, your range is 11 minus 4. Range is the simplest. It is the simplest tool. Simplest tool of studying dispersion. Formula for range is H minus L. H means highest value and L means lowest value. So range is highest, H minus L, highest value minus the lowest value. So you can easily find range if I have individual series. For example, from Monday to Saturday, 6 days, the prices of shares are, for example, Monday prices of shares is 200 in rupees. Tuesday prices of share is 210. Then next day Wednesday 208. Then next Thursday 160. Then Friday it becomes 220, and last Saturday it becomes 250. So can anyone tell me what will be the range? Very simple. Highest value minus lowest value. Can anyone tell? This is the easiest. Everyone can tell. Which is the highest value, children?
50.
Highest
Range
is
50.
yeah. No, not 50. Highest is 250. Smallest is 160. What is the answer? 90. Okay. So range is 90. Right? And along with the range, for dispersion we need to know, have the knowledge of coefficient of range. The formula is H minus L upon H plus L. Highest value minus lowest value upon highest value plus lowest value. So coefficient of range is 250 minus 160 upon 250 plus 160. So 250 minus 160 is 90 and 250 plus 160 is 410. So if I divide using the calculator, 0.22. Okay. So 0.22. Yeah, so fine. 0 point something is less only. So as the coefficients are less, there is less variation. As the coefficient goes on increasing, there is more variation. Right? This is the basic meaning of coefficient. We check the variations through coefficients. So this was the case of individual series. Next topic is range is done. Second is quartile deviation. I hope you remember the formulas for quartiles Q1, Q3. It will be recapitulated when we do the question. In quartile deviation, first topic is you should be knowing about interquartile range. Interquartile range. Interquartile range is, yesterday we studied Q1, Q3. Q3 minus Q1. This is interquartile range. And for this, after knowing this interquartile range, we divide by 2. That becomes quartile deviation. Quartile deviation we also write with QD is Q3 minus Q1 upon 2. Q3 minus Q1 upon 2. Right? So we can, the main purpose is, if quartile deviation is very small, it shows high uniformity, means high reliability. As the deviations are small, as the variation is less, it will be more reliable. I just discussed in the previous slide. As when quartile deviation is very small, it shows high uniformity, more consistency. It's good, more uniformity, and vice versa. So quartile deviation means the variation among central value. So all these dispersion methods of the dispersion we are taking out from central value, variation among the central items. How much is variation is from central item? Central item can be mean or median. So this was quartile deviation formula. Another formula is this is my school students' work. Okay. Another is coefficient. Coefficient of quartile deviation. It will be Q3 minus Q1 upon Q3 plus Q1. As we studied about coefficient of range, same way coefficient of quartile deviation. For everything we'll find the coefficients. For everything. Right? So these are the formulas. First is interquartile range, Q3 minus Q1. Quartile deviation, Q3 minus Q1 upon 2. And third formula, coefficient of quartile deviation, that is Q3 minus Q1 upon Q3 plus Q1. Let's apply in the example. Let's do the application part now. Calculation sums are lengthy but very easy, very easy. Now the question is, for example, I want to find the quartile deviation. I want to find the quartile deviation. So numbers I have, for example, 12, 15, 20, 28, 30, 40, 50. These are the numbers I have, right? And so n will be how much? 7. There are 7 items. This is individual series. There are 7 items and I want to find the quartile deviation. For this I will need to find Q1, then Q3, and then subtract and then divide by 2. So Q1, for Q1 I need the size of n plus 1. We have already discussed all these formulas in 2 sessions. N plus 1 by 4 item. So n is 7. 7 plus 1 by 4. 8. 7 plus 1, 8. 8 divided by 4, second. So second item which is 15. So Q1 is equal to 15. Similarly, Q3, it is size of 3 bracket n plus 1 by 4th item. So 3 into 8. 3 into 8 upon 4. It will be 6th item. So 6th item is Q3 is equal to 40. This is the 6th item, right? So we have found Q1. This is individual series. I'll discuss all the series with you. Discrete also and continuous also. One question, only one question. Not in detail. So Q1 and Q3 we have done. Now I want what? Quartile. I'll erase here only. Now I want quartile deviation. Quartile deviation is formula Q3 minus Q1 upon 2. Q3 is 40. 40 minus 15 upon 2. So 40 minus 15 upon 2. 40 minus 15 is 25. 25 upon 2 is 12.5. So deviation is 12.5. Now if I find coefficient of quartile deviation, it will be Q3 minus Q1 upon Q3 plus Q1. It will be Q3 minus Q1 40 minus 15 upon 40 plus 15. So 40 minus 15 is 25 and 40 plus 15 is 55. If I divide using calculator, it will be 0.455. So this much is the variation. 0.455 is the variation. Just have a look. If there is any doubt, please ask. Okay, let's start next. Now it will be a discrete series. In discrete series we have observations and frequency both. We have done ample of sums in the past 2 sessions. Let x be the observations and f is the frequency. Let it be 10, 20, 30, 40, 50 and 60. Let frequency be 4, 7, 15, 8, 7, 2. I hope you remember how to find Q1 and Q3 for this. So for Q1 quartiles we require commutative frequency. So 4 remains 4, 4 plus 7, 11, 11 plus 15, 26, 26 plus 8, 34, 34 plus 7, 41 and 41 plus 2, 43. And if you add up total, it is also 43. Right? So Q1 will be n plus 1 by 4th item. So it will be 43 plus 1 by 4th item. It will be 44 upon 4, 11th item. Now you need to see 11th item lies where? Clearly here only 11th item will lie, and Q1 will be corresponding value of the observation 20. So Q1 is 20. Similarly we find Q3. 3 n plus 1 by 4th item. It will be 3 into 11, 11th. 33rd item. So 33rd item will lie here and corresponding value will be 40. So Q3 is equal to 40. So once we have found Q1 and Q3, then there is no problem. Quartile deviation will be Q3 minus Q1 upon Q3 plus Q1. So Q3 is 40. Sorry, quartile deviation is Q3 minus Q1 upon 2. That is coefficient. 40 minus 20 upon 2. 20 upon 2. 10. So 10 is the deviation. And if I find coefficient of quartile deviation, this will be Q3 minus Q1 upon Q3 plus Q1. 40 minus 20 upon 40 plus 20. 20 upon 60. It will be 0.33. So this much is the variation. This was a case of discrete series. You can have a look. See, it's all the application using the formulas. Once we know the formulas, then it's very easy to apply. But rather than instead of applying, we should be more we should have more knowledge for the usage. What is the meaning? What is the conclusion? Interpretation is more required in statistics. That if you are using this tool, what is my observations? Right? Okay. Next comes the continuous series. Now in continuous series, let we have class interval. (33 to 35), 35 to 37, 37 to 39, 39 to 41, and 41 to 43. Frequency 14, 62, 99, 18 and 7. Cumulative frequency 14, 14 plus 62, 76, 76 plus 99, 175, 175 plus 18, 193, and 193 plus 7 is 200. Now in continuous series, we don't use n plus 1 by 4. We use n by 4. So for Q1 it will be n by 4th item. So n is 200. 200 by 4, it will be 50th item. So 50th item will lie here. And when it lies here, this will be the class interval to be used. So Q1 will be formula L plus n by 4 minus cumulative, I hope you remember, we have already done, minus CF upon frequency into iota. Lower limit is 35 plus n by 4, 50 minus CF we take off preceding class, I hope you remember. CF will be 14 upon frequency, corresponding frequency 62 into class interval difference 2. It will be 35 plus 50 minus 14, 36 into 2 upon 62. If we solve it, 35 plus 36 into 2, 72 upon 62. It will be 1.16. 36.16 is Q1, quartile 1. Similarly, we find quartile 3. So for quartile 3 we have 3n by 4th item. So 3n by 4 is 50. 3 into 50 is 1/50th item. So 1/50th item lies here, this one. So this will be the class interval to be used. So Q3 will be L plus 3n by 4 minus Cf upon frequency into I. L, lower limit 37 plus 3n by 4 150 minus Cf, previous one 76, frequency 99, I2. 37 plus 150 minus 76, 74 into 2 by 99. .49. It is 38.49. This is Q3. So quartile deviation will be Q3 minus Q1 by 2. 38.49 minus Q1, quartile 1, 36.16 upon 2. 38.49 minus 36.16 is 2.33 divided by 2. 1.16. This is the quartile deviation. And similarly we can find coefficient of quartile deviation, Q3 minus Q1 upon Q3 plus Q1. You can have a look. Next, I will erase this. Third topic comes, which is little bit lengthier one, mean deviation. Third topic, we have covered first two topics. I will move back and show you. Range done, quartile deviation done. So now we are going to start third topic. Mean deviation. It is also called average deviation. Right? So we have three series, different series, from mean deviation for individual series, for discrete series, and for continuous series. So when we take mean deviation, we take the absolute values. I hope you are aware of the absolute values. Means I mean to say modulus. For example, if I take -3, modulus will be 3, regardless of the signs. So modulus of 3 will be 3 itself, and modulus of -3 will be 3 only. So we discard the negative sign, we take its absolute value. So we have to use this absolute values in deviations. So for individual series, mean deviation formula will be 1 by n. I hope you know the meaning of the symbol summation. Summation means sum of all values. Modulus x minus a. And a you all know. A is the assumed mean. Okay. Or we can write mean deviation is equal to 1 by n summation modulus of d. D is same only, where d is x minus a. Now, application part of this can be find the mean deviation. Means deviation means variation you have to find from mean or from median. It can be anything. If you are asked find mean deviation from mean, that means you need to find mean first and then deviation and then put in the formula. If it is asked find mean deviation from median, then you need to find median first, find the deviation and put in the formula. I'll show you with the example. For example, there are two income group people. One group is of 5 members and second group is of 7 members. Group 1, group 2. There are two income groups people. So the incomes of first group people are 14,000, 14,800, 15,200, 16,000, 18,800. And for second income group people, incomes are 15,500, 16,000, 16,200, 17,000, 17,500, 18,000 and 19,000. I have to see the variation. I have to check the variations of these income group people. Right? So here, first income group, how many people are there? N is equal to 5. And for second income group people, N is equal to 7. Now I need to find deviation from mean. Or I can find deviation from median. Let us do mean we have already done. Let us do deviation from median. Right? So you all know how to find median for individual series. So this is odd and this is also odd. When we have odd data, median will be n plus 1 by 2th item. So n plus 1 by 2th item is, n is 5, 5 plus 1 6, 6 by 2 third item. So third item is just a second, his pen is not working, internet is slow. So third item is 15,200. So from this median I will find the deviation. So deviation will be x minus median. Deviation from median. So this is the median. 14,000 minus 15,200. I am taking the absolute value. I will not take negative sign. I will ignore that. I will use the absolute value. So 14,000 minus 15,200 will be 1200. 14,800 minus 15,200 will be 400. Same number subtracted from itself gives 0. 16,000 minus 15,200 gives 800. And 18,800 minus 15,200 gives 3,600. Now I'll find the summation because I need to use in the formula. If I add all these numbers, I'll get 6,000. Some summation will be 6,000. Right? Now I'll put in the formula. Mean deviation will be summation d upon n. It will be 6,000 upon n is 5. It will be 1200. Right? So deviation of the first income group people is 1200. Deviation of the first income group people is 1200. Now let's see the deviation for second income group. I'll erase this left portion only. So deviation of the first income group, mean deviation of first income group is 1200. I have written. Now let's see the deviation for second income group. So how much will be the median for second income group? Odd number, n plus 1 by 2th. 7 plus 1 by 2th. 7 plus 1 8. 8 by 2th, 4th. So fourth number is 17,000. Right? Now I'll find the deviation. X minus median. Median is 17,000. 15,500 minus 17,000 will be 1,500. 16,000 minus 17,000 is 1,000. 16,200 minus 17,000 is 800. This will be 0. 17,500 minus 17,000 is 500. 18,000 minus 17,000 will be 1,000, and here it will be 2,000. Summation is, if you add all numbers, 1500 plus 1000 plus 800 plus 500 plus 1000 plus 2000 will be 6800. Okay. Now mean deviation will be summation of deviation upon n. 6800 divided by 7. It will be 971.43. So mean deviation of first income group is 1200. 1200 is the variation from the central value, and for second income group the variation is 971.43. Means for the second group income group variation is less, and for first income group variation is more. This is the observation. And if we find coefficient of mean deviation, I haven't told the formula, I'll tell you. Coefficient of mean deviation is mean deviation upon median. If we are calculating mean deviation from median, then upon median. If we are calculating mean deviation from mean, then it will be mean deviation upon mean. So for first income group, mean deviation upon median. Mean deviation was 1200 and median was 15,200. It will be 0.079. And for second income group, mean deviation is 971.43 upon median is 17,000. It will be 0.057. So we can clearly see that here in first income group variation is more, and in second income group variation is less. Variation means deviation is less. This is the observation. You can have a look, and if you want to ask anything, you may. Shall we proceed for the next series? Any reply? Shall we proceed? So nobody wants to speak today?
मैम आपने कल कहा था कल को
Yes, बच्चे. Can you repeat?
आपने कल कहा था मैम कल करेंगे
नहीं, ये भी बच्चे इंडिविजुअल सीरीज हुआ है. अभी डिस्क्रीट और कॉन्टिन्यूस का देख के देन वी विल स्टैंडर्ड डेविएशन में कल कराऊंगी, बिकॉज इट्स अ वास्ट टॉपिक. स्टैंडर्ड डेविएशन विल टेक टाइम. तो स्टैंडर्ड डेविएशन में मॉर्निंग में करवाऊंगी 8 to 10. बट अभी मीन डेविएशन कंप्लीट करना है. मैंने कहा था कि फर्स्ट 3 टॉपिक्स कर लेते हैं, फोर्थ टॉपिक हम सुबह करेंगे. ओके
ओके मैम.
हाँ, अभी तक हमने वी हैव डन इंडिविजुअल सीरीज. आई एम मोर कंफर्टेबल इन इंग्लिश, सो आई होप आर यू कंफर्टेबल इन लैंग्वेज इंग्लिश? Yes, children, are you comfortable in English language?
Yes, ma'am.
Yeah. I speak Hindi. I know Hindi also. I know Punjabi also, but I am more comfortable in English because throughout the day at our work we have to speak English only. Okay, so this we have done individual series. Next is discrete series. Same topic but in discrete series. So we have to calculate mean deviation again from median. For example, we have observations and frequency. 10, 11, 12, 13, 14. Frequency is 3, 12, 18, 12, 3. Okay, and we total the frequency. It will be 48. Right? Now firstly, before we continue, the next step, firstly we'll calculate the median. So this is the discrete series, so median will be size of n plus 1 by 2th item. N is 48, 48 plus 1 by 2, 49 by 2, 49 by 2 is 24.5th item. So 24.5th item we need to have cumulative frequency. We haven't found, that is required. Then only we can search 24.5th item. 3 plus 12, 15, 15 plus 18, 33, 33 plus 12, 45, 45 plus 3, 48. So 24.5th item will lie here. So median will be corresponding value of x, 12. So median is equal to 12. Okay. So once we have found the median, I can erase this part. Even this I can erase. Even cumulative frequency I can erase. Not required. It was only required for median. Okay. So on the top we will write median is equal to 12. Now I need to find deviations. Deviations will be x minus median. So 10 minus 12, 2. 11 minus 12, 1. 12 minus 12, 0. 13 minus 12, 1. 14 minus 12, 2. Now formula for mean deviation is summation fd, because why fd? Because frequency is also involved now, upon n. This is the formula. So we need fd now. 3 2s are 6, 12 1s are 12, 18 zeros are 0, 12 1s are 12, 3 2s are 6. Summation will be 36. Right? So mean deviation will be summation fd 36 upon n 48. 0.75. So this much is the variation in this discrete series. You may have a look. Right? Okay. Now the 2-3 cases which we have done for mean deviation, we have done through median. Now if I ask you find the mean deviation from mean, then for that you need to find mean first, then deviation, then formula. And I hope you remember how to find mean. You have done in past 2 sessions. I'll take an example. I'm erasing this. I want to calculate mean deviation from mean. Mean deviation from mean. So we have observations and frequency. So we have 2, 4, 6, 8. I'll take easy question. 10, 12, 14, 16. I have frequency 2, 2, 4, 5, 3, 2, 1, 1. Now I hope you all remember how to calculate mean. Mean formula is summation fx upon summation f. Now fx we require 2 2s are 4, 4 2s are 8, 6 4s are 24, 8 5s are 40, 10 3s are 30, 12 2s are 24, 14 1s are 14, 16 1s are 16. Summation fx is equal to 160. Okay. Now how much is the mean? 160 upon summation f. Summation f 2 plus 2 plus 4 plus 5 plus 3 plus 2 plus 1 plus 1 is 20. So mean will be 8. 8 is the mean. Now once I have got the mean, now it's very easy for me to find the deviations now. Deviations will be x minus mean. Mean is 8. This is x. 2 minus 8, 4 minus 8, 6. This is mean. So 2 minus 8, 6. 4 minus 8. Though 4 minus 8 is minus 4. But I told you in the beginning, we are taking absolute values. 4 minus 8, 4. 6 minus 8, 2. 8 minus 8, 0. 10 minus 8, 2. 12 minus 8, 4. 14 minus 8, 6. 16 minus 8, 8. And then last column is FD. F and D. 2 6s are 12. 4 2s are 8. 4 2s are 8. 5 zeros are 0. 3 2s are 6. 2 4s are 8. 6 1s are 6. 8 1s are 8. Summation FD will be 56. We haven't find the answer yet. We have found the values. Mean deviation is summation FD upon n. Summation FD is 56 upon n is 20. 2.8. So that means 2.8 is the deviation of the table through mean, not through median, through mean we have found. Right? Last case, last topic, continuous series. And I will give you assignment today. You may note or take screenshot, your choice. But do it. Okay? Find mean deviation from median. 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70. These are the class intervals. Then we have frequency 7, 12, 18, 25, 16, 14 and 8. For median, we need to have community frequency 7, 12 plus 7, 19, 19 plus 18, 37, 37 plus 25, 62, 62 plus 16, 78. 78 plus 14, 92. 92 plus 8, 100. Right? So for median we need, because it is continuous series, so we will apply n by 2th item, not n plus 1. N plus 1 we use in individual and discrete series, not here. So here we have 100 by 2, 50th. So 50th item will lie here, and this will be the median class. So formula for median: L plus n by 2 minus cumulative frequency. This we have already done. I hope you remember. So L is 30, n by 2 50, cumulative frequency 37, frequency 25. CF will be preceding, frequency will be corresponding, into I is 10. If we calculate 30 plus 50 minus 37, 13 into 10, 130 divided by 25, 5.2. So final answer is 35. Not final answer, means median answer is 35.2 is the median. Our question is not over. We have found the median. Now I'll erase the extra portion which is not required, because all this task was done to find the median. Once we have found median, I can ignore the previous, erase the previous part. This CF also I can erase, not required. Now we'll find the deviation. Deviation will be x minus 35.2. So it's a decimal number, you need to be very, very careful now. But how we'll find x? Is the class interval. So before x we need to find the middle value. M. 0, mid value of 0 to 10 is 5. 10 to 20 is 15. 20 to 30 is 25. 30 to 40 is 35. 40 to 50 is 45. 55, 65. Now 5 minus 35.2. 30.2. 15 minus 35.2. Please, I request you to check the calculations with me. 20.2. 25 minus 35.2. 10.2. 35 minus 35.2. 0.2. 45 minus 35.2. 9.8. 55 minus 35.2. 19.8. and last 29.8. Once we have found the deviations, last step is FD. So this is F and this is D. So I will be using the calculator. 7 into 30.2. 211.4. 12 into 20.2. 242.4. 18 into 10.2. 183.6. 25 into 0.2. 5.0. 16 into 9.8, 156.8. 14 into 19.8, 227.2. 8 into 29.8, 238.4. Summation FD is, I will add them, 1314.8. This is, table is complete. Now formula, mean deviation, summation FD upon n. Summation FD is 1314.8 upon n 100. This is 13.148. So 13.148 is a bigger value. Deviation is too much. Right? Write the assignment, homework assignment. You may note or you may take screenshot, your choice. Find mean deviation from median. Class interval, or x we can say, is 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, and last 70 to 80. Frequency 5, 8, 12, 15, 20, 14, 12 and 6. You have to find mean deviation from mean. This is the first one. Second, I hope you remember grouping and analysis table. Find mode by grouping method. X is 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90. And frequency we have 5, 9, 13, 21, 20, 15, 8, 3. You may note or you may take screenshot. I repeat, this was the previous question. Find mean deviation from median. And find mode by grouping method. Last one more. Find Q1, Q3, P40, D6. X is 10 to 15, 15 to 20, 20 to 25, 25 to 25, sorry, 25, 25 to 30, 30 to 35, 35 to 40. You have frequency 5, 10, 15, 20, 10 and 5. This is the homework task. I'm showing the questions again. First question is find mean deviation from median. Second, find mode. Third question, find Q1, Q3, P40 and D6. Right? And tomorrow I repeat, class time morning 8 a.m. to 10 a.m. and I will be covering last topic of dispersion, standard deviation, and then I will be starting with the topic of correlation. Standard deviation, correlation I'll cover tomorrow. Correlation is very easy, very interesting. Standard deviation, it is requires your efforts and more of calculation, because it's the calculations are difficult. Not very difficult means you need to use calculator. And correlation is very simple topic, right? Okay, thank you. You may leave. Any problems you may ask, any doubts, not problems, any doubt you may ask. If no, then thank you. You may leave. Have a nice day.